Okay, we're now going to apply the ideas of conditional probability to a very famous, well-known problem called the Monty Hall problem. Okay, so the Monty Hall problem is really one of those classic problems that seems to confuse people. It also illustrates where some things can be pretty counterintuitive in probability, but there is an intuition for why it happens. Okay. So the original Monty Hall problem was like this. Okay. So let me just give you the idea behind how it was originally framed. I'm going to talk about it in a little differently in a minute, but how it was originally framed. It was originally framed on a TV show. I think the show was Let's Make a Deal. And the idea was that there were three doors. One of the doors had a car, and two had a goat. Okay, so you've got three doors in this TV show. I mean, you can kind of think of it like it was The Price is Right or something, where there was a game where you're gonna pick a door. So here's how the game works. So, geez. Three doors. All right. And now one of them has a car. So let's call this the car. And then the other two have a goat. All right. Now, the doors are closed, so you don't know, the contestant doesn't know which door has the car and which door has the goat. So step one is that you pick a door. Call this door 1, 2, 3. Okay. Pick a door. And the idea is you're going to get what's behind the door you ultimately pick, but there is a twist to this game. So you pick a door. Let's say you pick this one here. So you pick a door, number 2. And then the next step is that Monty Hall, who's the host of the show, but doesn't really matter if it's Monty Hall or someone else, but Monty Hall is going to open the unchosen door that contains the goat. So let's just be clear about that. So after I pick a door, there are two doors left. All right, there's this, oh geez. There's this door. And there's this door, doors 1 and 3. Now just think about it for a second, and unchosen door. So think about it for a second, is that no matter which door I picked, there's always going to be two doors left. And at least one of those doors will contain a goat, right? So if I actually picked the door with the car, both will have a goat. If I picked one of the goats, there's going to be a car and a goat. And so Monty Hall always has the option to show me a goat. And he always does show me a goat. Okay. So in this example, Monty Hall shows me a goat, or the goat. Okay, so he shows me this one. So he's going to open a door in blue that has the goat, a goat. I'm going to pick a door. In this case, that's the red. Oh no, that's the red. And then the question, and the third step, and then the final, more or less the final step. The third step is Monty Hall is offers the option to switch from my original choice to the unopened door. So just to color code this, the original choice was red, and now I'm being offered the option to, at this stage, let me color this now green, because and I want to have the option to, I have the option to switch. I can either keep my original choice, which was door number 2, or I can switch to the new door, to the only remaining unopened door, which is number 1. I'm not going to switch to the door that he opened because it contains a goat. I don't want a goat. I want a car. It's assumed that you want a car. Okay. So then the question, the question in the Monty Hall problem is, should you switch? Should you switch? Should you stay the same? Does it not matter? How do we think about this? Okay. Okay. So let's try to formalize this a bit. And let's try to answer this in terms of conditional probability. Okay. So let's write down. So how do we approach this? Well, let's just write down all the possibilities, right? So what are the possible arrangements? So what's the sample space? Okay. Sample space is the possible arrangements of doors. Okay. What are they? Well, in order, they're car, goat, 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 car, goat, 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 car. So it's really, it's really just a question of which door is the car behind, because there's 3 doors that the car could be behind, and the rest have goats. Okay. So that is those are the possibilities, right? And so let's think about, okay, you've got door 1. Well, okay. So let's say we're in possibility. So suppose we pick door number 2. As we did here. Then the question is, we have the outcome. And then what we have is we have the result if we stay, meaning we don't change, and the result if we switch. Stay with number 2, and the result if we switch to the other door, whichever it is. So outcome CGG, outcome GCG, outcome GGC. Well, if we stay at 2, then what are we going to be left with? So just to be clear, if we stay at 2, we get this. So the result here is G, C, and G. If we switch, so this is the result if we stay, and the result if we switch, highlight in purple. So in this case, if we switch, so we're going to be shown this goat, or we're going to be shown a goat, right? So in this case, we're going to be shown this goat. In this case, we can be shown either goat, okay? Be shown the first goat. And in this case, we're going to be shown this goat. So if we switch, we're left with this, this, and this. So we have car, car, no, car, goat, car. Right? So if we stay, there are 2 goats in 1 car. So the probability that we win the car, given that we stay, is 2/3. If we switch, probability of winning the car is 2/3. I'm sorry. If we stay, probably is 1/3. If we switch, probably is 2/3. So we should switch. And the reason this is such a controversial problem is that the intuition might be, well, you're always going to show me a goat. So you haven't actually given me any information when you haven't actually given me information by showing me a goat, because I knew you were going to show me a goat. Okay, so that's one intuition is, so why is this controversial? Is on the one hand, if I know you'll show a goat no matter what, there's no information gained. In learning, in opening the door with the goat. So we should just ignore it. This is where it gets a little subtle, is that that's not the whole story. The whole what that this is not quite right, evidently. There's no information gained. Why not? Yes, I know you're going to show me a goat, but prior to you opening the door, I don't know which door you're going to open to contain the goat. So the information is in which door contains a goat. Okay. Okay. So I'm not learning that there's a goat. I'm learning that the specifically which door I should eliminate. Okay. And in 2/3 of the situations, what happens is I selected a goat to begin with in 2/3 of the situations, right? Because we assume that the door I pick is selected at random, more or less, or that what's behind it is 2/3 goat, 1/3 car. So 2/3 of the time I've picked a goat to begin with. What does that mean? That means that there's a goat in a car. And so what I've done in 2/3 of the situations is, and what I've done is I have two choices. I've actually identified two options, a car and a goat, and you're going to tell me which one's the goat specifically. And then I know that I can just pick the other one and I have a car. That's in 2/3 of the situations. So in 2/3 of the situations, I guarantee myself a car. And so the way to think about this is actually not in which door I picked, but in the two doors that I didn't pick. Right? So another way to think about it which makes it, I think, a little bit easier, is in terms of doors that I didn't pick, that were not chosen. Okay. So in terms of doors that were not chosen, let's imagine, so doors, so we order the doors left to right, and define the possible outcomes as door one, door two. So door one is the left door that was unchosen, the leftmost door that was not chosen. So door one is the prize behind the left door that's not chosen. Door two is the prize behind the rightmost door not chosen. Okay, so then what are the possibilities? Well, possibilities are that the car, again, the possibilities up here were CGG, GCG, and GGC, but that ignores that doesn't have take into account what we picked. Okay, so what I can pick is I can have a situation where the car is in the left, the goat is in the right. Case where I pick the car is I'm going to have a goat on either side, or I'm going to have two goats, or the case where I pick a goat, but the goat is in the left and the car is in the right. Okay. So these are the possibilities. And they all have equal probability. And so the probability that I win a car, given that I switch. So when do I win a car? I win a car in the situations. So when I switch, the situations I win a car are CG or GC. Right? Because if it's CG or GC, the goat is going to be told, I'm going to be told about the goat, so I can just pick the car. And if I'm in GG, obviously I have no chance. GG. So that's another way to think about it, is instead of thinking about it, what car you pick, or what door you pick, think about it in terms of what door you don't pick. So that's the Monty Hall problem. And it's something that can really kind of develop some intuition to make sure we can work through this in a little bit more of a formal fashion. So what this example does for us is it shows us, number one, is that there's some subtlety in conditional probability that we, at first glance, we might not notice, so we have to be careful. And that subtlety in this case is shown up here, is that the initial idea is that there's no information gained. And once we get rid of, since you're going to show me a goat anyway, I know that one of the two remaining doors, the one I picked or the one that's not open that I didn't pick, has equal, well, one of them has a car and one of them doesn't. I knew you were going to show me a goat to begin with, so it's 50-50 and it doesn't really matter. So that's one of the, that's the traditional kind of immediate reaction to it. Why that is wrong is ultimately because it ignores the starting point, which is what were the possibilities to start with, and it ignores that additional information of it's not about knowing that you were going to show me a goat. It was actually about that you're going to point it out where that goat is, which door you're actually going to show me, and then I know I can pick the other door. So it's a bit more subtle, and we have to be careful. And there's some more formalized machinery that we can develop, and we will develop in the next section to be able to handle situations like this.